Albert Einstein was very adept in putting himself into altered states of consciousness through what he called his thought experiments, which were a kind of three-dimensional metaphorical reverie.
Albert Einstein, one of history's greatest scientific minds, transformed our understanding of the universe. But despite his genius, he once dismissed certain aspects of quantum mechanics, calling it spooky action at a distance.
Thought experiments enable you to visually or geometrically approach a problem that maybe mathematically might be difficult.
He believed the universe operated by strict, predictable rules, but quantum computers have now just turned his theory on its head. How did these powerful machines manage to challenge Einstein? And what does this mean for science, technology, and our understanding of reality itself? Stick around, because what we're about to reveal will leave you shocked. Einstein's connection to quantum computers and how they proved him wrong. Before we get into how quantum computers and computing in general proved Einstein wrong, we need to first find out how he is connected to this aspect of physics in the first place. In the early 20th century, scientists started discovering new things about how tiny particles, like electrons and photons, behave.
Atoms are not the end of the story, too, because we have electrons zooming around the nucleus. Deep inside, mostly empty space in the atom, but deep inside, we see the nucleus.
These discoveries led to the creation of quantum mechanics, a field of science that tries to explain the behavior of these tiny particles.
So if I start with an electron in one corner of the room, and I say, what's the probability at some time later it'll be somewhere else? Then at every point in the room, you can assign a probability that it will be there at a later point, with one simple rule.
While many scientists were excited about quantum mechanics, Einstein was not convinced. He felt that quantum mechanics was incomplete because it didn't explain everything in a clear, logical way. Then, he decided to do something about it. In 1935, Einstein, along with two other physicists, Boris Podolsky and Nathan Rosen, wrote a famous paper about a strange quantum phenomenon. This phenomenon is now called quantum entanglement. They described how two particles, once entangled, seem to remain connected no matter how far apart they are. For example, if you measure one particle and find out it's spinning in a certain direction, the other particle will instantly have the opposite spin, even if it's light years away.
We scientists who release this immense power have overwhelming responsibility in this world life and death struggle to harness atom.
Einstein didn't like this idea because it seemed to break one of the rules of physics, that nothing can travel faster than the speed of light. He called this spooky action from a distance. He believed there must be some hidden variables or rules we didn't yet know about, which would explain the behavior of these particles in a way that didn't require spooky action. But over the years, experiments began to show that Einstein's idea about hidden variables was likely wrong. One of the most important experiments happened in the 1960s, long after Einstein had passed away. A physicist named John Bell came up with a way to test whether hidden variables existed. His work led to what are now called Bell tests, which proved that particles really do behave in the strange way described by quantum mechanics. This meant that quantum entanglement was real, and there wasn't a simpler explanation hidden behind the scenes. Fast forward to the late 20th century. In the 1980s and 1990s, scientists started exploring how the weird rules of quantum mechanics could be used to build new types of computers. These computers, called quantum computers, are very different from the ones we use every day.
They've demonstrated with the quantum computer that it can perform a computation in seconds what would take the world's fastest supercomputer years, thousands of years, to do that same calculation. And in the field, this is known as quantum supremacy, and it's a really important milestone.
Normal computers use bits, which can be either 0 or 1, to process information, but quantum computers use qubits, which can be 0, 1, or both at the same time, thanks to a quantum property called superposition. This allows quantum computers to perform many calculations at once, making them incredibly powerful for certain tasks. That's not all. Another important feature of quantum computers is their use of entanglement. When qubits are entangled, changing the state of one qubit instantly changes the state of the others, no matter how far apart they are. This property allows quantum computers to solve problems that would take classical computers millions of years to complete. The rise of quantum computing gave scientists new tools to explore the mysteries of quantum mechanics. They could now run simulations and experiments that weren't possible before. Some of these experiments have even challenged Einstein's views about how the universe works. One of the most exciting recent experiments using quantum computers happened in the early 2020s. Scientists used quantum computers to explore the connection between quantum entanglement and space-time, the fabric of the universe described by Einstein's theory of relativity. This experiment was groundbreaking because it suggested that space-time itself might emerge from quantum processes. Apart from this experiment, there were several others that somehow showed the philosophical and neurological relationship between quantum physics and the human mind. Keep watching to discover what this relationship is. Relationship between quantum physics and the human mind. Over the past century, quantum physics has not only changed how we understand the physical world, but also raised deep questions about the human mind. Could our thoughts and consciousness be connected to the same rules that govern particles? Scientists and philosophers alike have been pondering this question for decades, and one of the most puzzling conclusions they came to is a strange concept in quantum mechanics is the observer effect. This concept comes from experiments like the double-slit experiment, which was first performed in 1801 and later adapted for quantum particles in the early 1900s. In this experiment, scientists discovered that particles like electrons behave differently when they are being observed. When nobody is looking, the particles seem to exist in a cloud of possibilities, taking all paths at once. But the moment someone observes them, they choose a single path. This strange behavior raises an important question. Does the act of observation influence reality? Things don't end there. Philosophers and scientists have also explored the idea that consciousness, the human ability to think, perceive, and make decisions, might play a role in shaping the universe. Some even believe that reality itself is not fixed, but depends on how we observe and interact with it. This ties into the holographic principle, a theory that suggests the universe might be like a giant hologram, with everything we see and experience being a projection of deeper, hidden processes. In the 1990s, a scientist named Roger Penrose and a doctor named Stuart Hameroff proposed a bold theory about how quantum physics might be connected to the human mind. They suggested that consciousness could arise from quantum processes happening inside tiny structures in our brain cells called microtubules. Microtubules are part of the cell's skeleton, and they play a role in how cells communicate and function. According to Penrose and Hameroff, these structures might be small enough to be influenced by quantum effects, like superposition and entanglement.
I think consciousness is happening in the brain, in the microtubules, but at the level of fundamental space-time geometry. Now, when the blood stops flowing and the oxygen stops being delivered, the quantum coherence, the membrane physiology goes first, and eventually the microtubule coherence is lost.
If their theory is correct, it could mean that our thoughts, memories, and even our sense of self are deeply tied to the strange world of quantum mechanics. It might also explain why the human brain is so powerful and creative, capable of solving problems, imagining new ideas, and experiencing emotions in ways that no computer can fully replicate. This theory has caused a lot of debates among scientists. Some argue that the brain is too warm and noisy for delicate quantum effects to occur. Others believe that quantum mechanics could hold the key to understanding mysteries like free will, intuition, and even the possibility of life after death. That being said, as with every new scientific exploit, there have been many questions regarding the ethics around quantum computers and quantum mechanics at large. Stay tuned to find out what these questions are. Ethical questions regarding practical applications of quantum computers. Just as we already established earlier, quantum computers are not like the computers we use every day. They are far more powerful, and they work in ways that seem almost magical. While regular computers process information using bits, ones and zeros, quantum computers use qubits, which can be both 1 and 0 at the same time. This ability to exist in multiple states, called superposition, allows quantum computers to solve problems that would take normal computers millions of years. But with great power comes great responsibility.
But just like the superposition of waves and music leads to richer and more interesting sounds, quantum superposition leads to richer and more interesting technology, from powering faster algorithms in quantum computers to securing communications through new cryptography and more.
As quantum computing becomes more advanced, it raises ethical questions about how we use this incredible technology. Will it improve lives, or will it create new risks that we aren't prepared to handle? One of the biggest ethical issues with quantum computing is its impact on cybersecurity. Most of the internet today is secured by encryption, which scrambles information so that only people with the right key can read it. This includes everything from online banking to private emails. Traditional computers would take thousands of years to crack these codes, but a quantum computer could do it in minutes. This poses a serious risk. If hackers get access to quantum computers, they could break into government databases, steal personal information, or even disrupt entire economies. This possibility has made many experts worry about a quantum arms race, where countries and companies rush to develop quantum computers for security purposes. To address this, scientists are working on quantum-resistant encryption, which would be safe from quantum attacks. But creating and implementing these systems takes time. If quantum computers become widely available before we're ready, the consequences could be devastating. Wait, there's more. Another exciting yet controversial application of quantum computing is artificial intelligence, also known as AI. Quantum computers could make AI systems much smarter and faster. For example, they could help AI analyze huge amounts of data, recognize patterns, and make decisions in ways that seem almost human. This could lead to breakthroughs in fields like medicine, where AI could help doctors diagnose diseases more accurately, or in climate science, where it could predict weather patterns with incredible precision.
Realize that life is based on molecules. Molecules that can create Alzheimer's disease, Parkinson's disease, cancer. These diseases are beyond the reach of digital computers. But hey, this is what quantum computers do.
But this also raises ethical questions. What happens if AI becomes so advanced that it starts making decisions without human oversight? Could we accidentally create machines that think and feel like humans? If so, would these machines have rights? Would it be ethical to turn them off or use them for dangerous tasks? These questions may seem far-fetched, but as quantum computing pushes the boundaries of AI, they become more urgent. Quantum computers also work by manipulating quantum systems, which are governed by the strange and unpredictable rules of quantum mechanics. This raises another ethical issue. How far should we go in using these systems for practical purposes? For example, quantum computers could help scientists design new materials, medicines, and technologies. This is exciting, but it also comes with risks. What if these technologies are used in harmful ways? For instance, quantum computing could be used to create more powerful weapons or surveillance systems that invade people's privacy. Additionally, manipulating quantum systems might have unintended consequences. Some scientists worry that tampering with quantum processes could disrupt natural systems in ways we don't fully understand. While these risks are theoretical for now, they show the importance of using quantum technology responsibly. With so much potential for both good and harm, many experts believe that quantum computing needs strong ethical guidelines. Governments, companies, and scientists must work together to ensure this technology is used for the benefit of humanity. One suggestion is to create international agreements, similar to those used for nuclear weapons, to prevent the misuse of quantum computers. These agreements could include rules about how quantum computers are developed, who has access to them, and how they are used. Another important step is education. As quantum computing becomes more widespread, people need to understand its risks and benefits. This includes not just scientists and engineers, but also policymakers, educators, and the general public. One of the most important lessons from history is that technology is only as good as the people who use it. The same quantum computer that can help scientists design life-saving medicines could also be used to create destructive weapons. This is why ethics must play a central role in the development of quantum technology. As we move forward, it's up to all of us to ensure that quantum technology is used for the greater good. By addressing these ethical challenges now, we can build a future where quantum computing improves lives, solves problems, and helps us understand the universe in ways we never thought possible. The terrifying signal. For nearly 50 years, Voyager 1 has traveled farther than any spacecraft in history, sending back information about space. But now, something strange has happened.
The most important reason for sending the thing out there is to get the science data back. And so the instruments are taking visible pictures, infrared pictures, measuring particles in the case of Voyager. We need to get that data back down and distribute it to the scientists.
Scientists have picked up a mysterious signal from Voyager 1, over 15 billion miles away. This signal, described as a faint and unexplainable pulse, feels like a whisper coming from the edge of the universe, and no one knows what it means. Voyager 1 was launched in 1977 to explore the outer planets and has since moved beyond our solar system, entering interstellar space.
NASA confirmed Thursday that the Voyager 1 probe has made history by becoming the first human-made object to leave our solar system and interstellar space.
For decades, it has sent back data about this distant region, but this new signal is completely unexpected. It raises exciting and unsettling questions. Is it caused by something unknown in space, or is Voyager 1 itself showing signs of trouble after working for so long? This discovery is important because it's so unusual. Space is mostly silent, so when something like this happens, it gets everyone's attention. Wait till you find out the main reason why. The signal was noticed during regular checks of Voyager 1's transmissions. At first, it didn't seem like the usual data. It was faint and irregular but seemed to follow a pattern. But it wasn't just random noise or a simple glitch. Engineers thought it might be a problem with Voyager 1's old instruments, and since the spacecraft has been working for decades in extreme conditions, it wouldn't be surprising if something broke down. But after careful checks, no errors were found in the equipment. The signal continued, confusing everyone. Some scientists believe the signal might be caused by something in interstellar space, like strange activity from cosmic rays or interactions with charged particles. Voyager 1 has detected plasma waves in the past.
March of 2012, it turns out there was a massive eruption from the sun which eventually reached Voyager 1 in April of 2013. When that blast wave reached Voyager, it caused the plasma around Voyager to vibrate or oscillate in a certain particular tone.
But this signal was different. Other speculations say it could be something unusual, like signals bent or magnified by gravity from massive objects like stars or black holes. While this idea sounds unlikely, space is full of surprises, and we still don't know everything about it. There's also a chance the signal is coming from Voyager 1 itself. After 46 years, its systems are old and wearing out. This could be a sign that the spacecraft is struggling to keep working. No one knows for sure what's causing the signal, but this unexpected event has sparked curiosity around the world.
The signal has to be, in some sense, above the noise level for us to see it. You first of all just try to filter the noise out as much as possible just from a frequency standpoint.
Background of Voyager 1. Voyager 1 was initially part of NASA's Voyager program, along with its twin, Voyager 2. The primary goal of the program was to take advantage of a rare planetary alignment that occurs roughly once every 176 years. This alignment allowed the spacecraft to use a gravity assist technique, where the gravitational pull of one planet propels the spacecraft toward the next, conserving fuel and extending its journey. The original objectives focused on studying Jupiter and Saturn. At Jupiter, Voyager 1 provided the first detailed images of its atmosphere, revealing complex weather systems, including the famous Great Red Spot. It also captured stunning views of the planet's moons, such as Io, which was discovered to have active volcanoes, the first known outside Earth. For Saturn, Voyager 1 discovered the structure of its rings and sent back data about Titan, Saturn's largest moon. Titan's thick atmosphere, rich in nitrogen, was so fascinating to scientists because it resembled early Earth's conditions. But that's not all. After completing its primary objectives, Voyager 1 continued on its journey, heading toward the outer reaches of the solar system. Its secondary mission was to study the heliosphere and eventually cross into interstellar space. This is a feat it achieved in 2012, becoming the first human-made object to do so. One of Voyager 1's most iconic contributions to humanity is the Golden Record. This 12-inch gold-plated disc, attached to the spacecraft, contains sounds and images intended to represent the diversity of life and culture on Earth. Curated by a team led by astronomer Carl Sagan, it includes greetings in 55 languages, music from around the world, natural sounds, and encoded images. While it was primarily a symbolic gesture, the Golden Record serves as a time capsule and a message to any extraterrestrial intelligence that might encounter the spacecraft. Despite being in operation for 46 years, Voyager 1 continues to transmit data using its 1970s-era technology. Its nuclear-powered radioisotope thermoelectric generators still provide enough energy for limited operations. The spacecraft regularly sends information about cosmic rays, magnetic fields, and the interstellar plasma environment. These data help researchers understand how our solar system interacts with the broader galaxy. Voyager 1 is currently over 15 billion miles away from Earth, making it the farthest human-made object in existence. At this long distance, signals traveling at the speed of light take over 22 hours to reach Earth and another 22 hours for a response to return. The spacecraft operates under extreme conditions, where temperatures are near absolute zero, and its systems endure the wear and tear of decades-long use. NASA engineers have adapted its operations to conserve power, turning off non-essential systems and using backup components when possible. Last year, Voyager 1 experienced communication issues due to a glitch in its flight data system, but engineers were able to partially resolve the problem by sending corrective commands. Description of the signal. The signal in question arrived as a garbled, indecipherable stream of data from Voyager 1's flight data system. Normally, this system packages science and engineering data before transmitting it back to Earth. But this particular transmission bore no resemblance to the spacecraft's usual format. Engineers described it as resembling a monotone or nonsensical dial tone when decoded into binary. It brought to mind what one would think alien speak looked like. But before jumping to conclusions that the data was proof of aliens, the Voyager 1 team had to exhaust every other possibility. The fact that this odd signal was coming through, even though Voyager 1 had been maintaining communication and responding to commands from mission control, was even weirder. This suggested that while the spacecraft's hardware remained functional, something had interfered with the data processing or transmission. In March this year, after issuing a corrective command, NASA managed to retrieve a partial memory readout from the FDS. The readout revealed a mix of standard instructions and unexpected anomalies, hinting at a deeper issue within the onboard systems. What happened next was the surprising part. Although the signal wasn't immediately alarming, its unpredictability added to its significance. For a spacecraft operating billions of miles from Earth with decades-old technology, any deviation can potentially signal the end of the mission or an entirely new discovery. Voyager 1's transmissions are a useful source of information about the interstellar medium, the environment outside the solar system. The spacecraft's ability to consistently send data has been key to understanding cosmic radiation, magnetic fields, and plasma waves in this unexplored region, and this terrifying signal disrupted that. First, there was the possibility of a hardware failure, which could severely limit Voyager 1's ability to communicate. Second, the signal hinted at an unknown phenomenon, whether related to interstellar space or an issue with the spacecraft itself. Voyager 1's systems are over 4 decades old, operating in a harsh environment billions of miles from Earth. It was possible that the flight data system, responsible for processing and transmitting data, could be experiencing wear and tear. NASA engineers suspect that corrupted software or a degraded component within the FDS may have caused the anomaly, but there's another possibility. With Voyager 1's location in interstellar space, the signal could also have been influenced by external cosmic phenomena. The spacecraft routinely detects plasma waves, a natural occurrence in interstellar space caused by charged particles moving through the plasma. But if the signal were linked to such an event, it would typically have been recognized as part of the spacecraft's regular science data. High-energy cosmic rays or unexpected radiation bursts could potentially interfere with Voyager 1's systems, introducing errors into the data stream. Although the most likely explanations involve mechanical or cosmic factors, the terrifying signal has prompted some to ponder more extraordinary possibilities. Could the signal represent something truly unfamiliar? Perhaps even a sign of an unknown phenomenon in interstellar space? NASA's engineers are continuing their meticulous investigation into the signal. By comparing the anomaly to previous transmissions, they hope to pinpoint whether the issue lies within Voyager 1's systems or was influenced by its environment. The investigation into terrifying signal. When NASA first detected the garbled signal from Voyager 1, the mission team immediately began an extensive investigation to uncover what went wrong. This process ran deep, as troubleshooting a spacecraft operating over 15 billion miles from Earth involves significant challenges. Every step had to be precise, considering the nearly 22-hour delay for a single command to reach the spacecraft and the same time for a response. The first clue came from Voyager 1's telemetry, which showed that the spacecraft's hardware was still operational and its communications system was intact, but the data being sent back was incomprehensible. Engineers traced the issue to the flight data system, as it appeared to be routing data to the wrong locations in memory before transmission, resulting in a garbled signal. This issue was critical, as telemetry data not only informs Earth about the spacecraft's health, but also provides valuable insights into the interstellar environment. If the problem wasn't addressed, it could jeopardize Voyager 1's ability to fulfill its mission. With no possibility of a physical repair, the team relied entirely on remote commands. NASA engineers sent diagnostic queries to retrieve specific snapshots of the spacecraft's memory. By analyzing these memory snapshots, they could determine whether the data corruption was occurring during storage, retrieval, or transmission. The findings confirmed that the FDS was functioning but misrouting telemetry data to an incorrect part of its memory system. This analysis ruled out immediate concerns like a total system failure or a critical hardware breakdown. Instead, it suggested a possible corruption in software commands or damage to memory sectors caused by cosmic radiation, a known risk for spacecraft operating in deep space. After identifying the likely misrouting issue, NASA engineers worked on solutions that wouldn't overburden the spacecraft's limited power and resources. They reprogrammed the FDS to bypass the problematic memory sectors, redirecting data to functional areas. This required precise coding and testing, as even a minor mistake in the command sequence could worsen the situation. But they didn't stop there. They also utilized the spacecraft's redundancy systems. Voyager 1 was designed with backup components for many of its critical systems. Engineers activated these redundancies to ensure that essential functions like data transmission and storage could continue without interruption. Once the immediate problem was addressed, NASA began long-term monitoring of Voyager 1 systems. Regular diagnostic commands are now being sent to track the spacecraft's performance and detect any new anomalies. The team remains vigilant, knowing that Voyager 1's advanced age makes it increasingly susceptible to system failures. This investigation highlighted the challenges of managing a spacecraft that operates so far from Earth. Despite the anomaly, Voyager 1 continues to send valuable data about outer space, offering insights into regions of space no other spacecraft has explored. What do you think of the terrifying findings on Voyager 1?
The arrival of the Oumuamua into our solar system has indeed opened the eyes of many scientists to reality. All over the world, there is an awakening as mankind has become fully aware of the benefits of understanding the universe. But not only that, we are also aware that ignorance has consequences, which no one would like to bear. In the past few decades, so much has been done to plant man's feet on the ground in space exploration. Satellites have been launched and telescopes have been created, alongside rockets with spacecraft going on missions. As this is so much effort being put in, it is easy to think that we are likely prepared for the worst. But this thought had only lasted until Oumuamua tumbled in on us with such speed, shape, and mystery that tells us that we were never prepared for it.
Well, do you agree that Einstein was wrong about his opinions regarding quantum computers? Leave your opinions in the comment section. Remember to like, share, and subscribe for more. Also, click the following video shown on your screen. You will enjoy it.